Sir, Rajsekhar, sir. Sir, sir, Rajsekhar, sir. Rajsekhar, sir. Sir, Rajsekhar, sir.
Ready, sir.
Sir, start the program, sir. Okay.
Sir, ready.
Sir, you can start the program, sir.
If you get up in the morning and think the future is going to be better, it is a bright day, otherwise it is not. Good morning to one and all present here. On behalf of PG and Research Department of Mathematics, DG VAISHNAV College, I welcome all the CSIR aspirants. Prayer is talking to God Almighty, the creator of whole universe. So let's begin our session with the presence of God. Now Tamithal Vathu, followed by college prayer.
நீராறும் கடலொடுத்த நிலமடந்து எழிலொழுகும் சீராரும் வதனமென திகழ்வரத கண்டமிழி எக்கணமும் அதிசிறந்த திராவிடனல் திருநாளும் தக்க சிறு பிறை முதலும் கரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம்பியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
सत्यव्रतं सत्यपरं त्रिसत्यं सत्यस्य योनिं निहितं च सत्ये सत्यस्य सत्यं ऋतसत्यनेत्रं सत्यात्मकं त्वां शरणं प्रपन्नाः वाणी गुणानुकथने श्रवणो कथायां हस्तौ च कर्मसु मनस्तव पादयोर्नः स्मृत्यां शिरस्तव निवास जगत्प्रणामे दृष्टिस्ततां दर्शनेस्तु भवत्तनूनां नमो भगवते तस्मै कृष्णायाद्भुतकर्मणे रूपनामविभेदेन जगत्क्रीडति यो यतः ॐ शान्ति शान्ति शान्तिः.
Sir, Rajsekhar, sir. Okay, voice clear. Good morning to all. It's my great pleasure to introduce our resource person, Dr. R. Sivaraman, Associate Professor, PG and Research Department of Mathematics, DG VAISHNAV College, Chennai. Dr. R. Sivaraman, currently working as Associate Professor of Mathematics at DG VAISHNAV College, ARUMBAKKAM, Chennai. He has 22 years of teaching experience. His area of interest are number theory, mathematical analysis, and applied mathematics. He has published more research papers including 15 Scopus indexed, 15 UGC CAR, and 5 Web of Science indexed in various national and international journals. He has provided several invited talks at national and international conferences. He has guided 7 MPhil students successfully so far. He is reviewer, member of editorial board for 12 national and international, including Scopus, UGC CAR, and Web of Science, indexed journals in mathematics. He has been involved as resource person in training teachers appointed by Teachers Requirement Board, RMSA, and SSA. He has been conferred with honorary Doctor of Letters from California Public University, America, and honorary Doctor of Science from University of Swahili, Republic of Panama, Central America. He has qualified in Junior Research Fellowship as well as NET combined category conducted by CSIR. He has also secured All India 27th rank in the Graduate Aptitude Test for Engineering exam conducted by IIT Madras with a percentile score of 96.3. He has been conferred with National Award for popularizing mathematics among masses in 2016 by Department of Science and Technology, Government of India. He was conferred with the Indian National Science Academy Teaching Award for the year 2018. This award is the greatest recognition for a teacher working in college, university throughout India. He has also received 2 state government best book awards in science for consecutive years 2011 and 2012 so far. He has received 9 best book awards for the 20 books written for mathematics and science. Among these 20 books, 15 were in Tamil and 5 in English. He has provided more than 300 lectures throughout India, conveying the beauty of importance of mathematics and its applications. Spreading mathematics among everyone was his life vision. He is life member of the mathematical organizations like American Mathematical Society, London Mathematical Society, Indian Mathematical Society, Ramanujan Mathematical Society, and Mathematics Teachers Association. He is the founder trustee of Pi Mathematics Association. He is currently editor of the journal Junior Mathematician, a quarterly mathematics journal for school students published by Association of Mathematics Teachers of India. He is also serving as editor of e-magazine Mathematical Pixels, published by Pi Mathematics Association from 2020. He was a member of a team appointed by State Government School Education Department for preparing 100 mathematical models for 100 corporation schools in 2008. He was also a member of Textbook Writing Committee, Tamil Nadu School Education Department for preparing revised mathematics text for 11 in new syllabus. He was chairperson of the 10th class new mathematics textbook released in June 2019. He was recipient of more than 40 awards like Mathematics Popularization Award, Abdul Kalam Teaching Experience Award, Abdul Kalam Scientific Excellence Award, Abdul Kalam Global Teacher Award, Best Research Scientist Award, Distinguished Professor Award, Distinguished Mathematician Award, Golden Peacock Best Professor Award, Research and Innovation Award, Outstanding Scientist Award, Research Excellence Award, Best Researcher of the Year Award, Radhakrishnan Fellowship Award, Indo-Asian Distinguished Mathematician Award, Isaac Newton Research Scientist Award, International Lifetime Achievements Award, and much more for his wide contributions to mathematics. He writes regular articles and provides puzzles for famous newspapers like the New Indian Express, Times of India, the edition paper, Tamil Hindu, Dinamalar Pattam newspaper. He has also contributed several articles about mathematics in monthly magazines like Chutti Vigadan, Manjrani, Ariviyal Oli, Chennai Report, and Arumbu. With this brief introduction, I welcome you, sir. Now I hand over the session to you, sir.
So, good morning to one and all. I'm very happy to be part of this C4 program. Being a teacher of real analysis, I would call C4 as R8 because C is isomorphic to R2. So, C4 becomes R8 in my version. Anyway, we are going to discuss about some of the problems that were asked in the previous year's question papers in real analysis, and that is the objective of today's lecture. So we will straight away see the content. How to share the screen? Is it visible, the screen? Please provide the screen sharing option.
Sir, just share your screen share. I will add the screen share.
Is it visible?
Share? No, sir.
No, I don't get this share option here. The share option is...
Share top camera, mic. The next option is share screen, sir. Then share the screen.
No, I share option varling in game. Share no varla on agala. It is in off state.
Sir, your screen not visible, sir.
Okay.
Just to close and share one more time, sir.
Now is it visible?
No, sir.
Now the screen is visible?
No, sir. Not visible, sir.
See, when we discussed this screen share option is on. Ipo on agli enakku.
Appdingla, sir. Sir, again close பண்றதால வரும், sir. Just. Yes, sir. Now, yes, sir. Now, okay, sir. Okay. Okay, sir. Now open the PPT, sir.
Okay.
Yes, sir. So, slide view, sir. Next, slide view, sir. Okay,
now?
sir. Yes, sir. Yes, sir. Perfect, sir. Sir, just on the hide button, sir. Stop sharing. Next, hide button.
So,
just
at the outset, I will be discussing some of the problems asked in the previous year's question papers. As I told you, we will start with part A questions. I am going to discuss questions from all these sections, section A, section B, and section C, which are to my preference. These are all questions asked in the previous year's papers, last 5 years or 6 years or so. Not so old, but some of the papers, recent papers. Now, for the first question, you are given 3 numbers in the form ABC. The answer is given to be C, C, C. ABC has 3 distinct digits as per the question. This is a single option question, as in section A, you get only one option correct. Now, if you add 3 C's here, the answer is C in the units digit here. And that is possible only when C is 5. So if you take C is 5, you get 3 5's adding up to 15 here, or 0. C can also be 0 here. If you add 3 zeros, you get 0. But there's no option for C0 here, as you can see. So there are only 2 numbers, 0 and 5, such that if you add 3 times, you get the same digit in the units place. So 0 plus 0 plus 0 is 0, or 5 plus 5 plus 5 is 15, you get 5 over here. So because C happens to be 5, the answer is either the first option or the third option. It should either be first, because here C is 1 and here C is 3. If you add 1 3 times, you get 3 only, so you don't get C1 here. And if you add 3 times 3 times, you get 9, so that is also incorrect. So only either the answer is first option or the fourth option. In this case, if I choose, suppose C is 5, C is 1 here, C is 5 here, then you get 5 plus 5 plus 5, 15. 1 carries over here. Now listen, this place, tens place is also C here, which means C is 5 here, so I should get 5 over here. So if I choose 5 here, then 1 carries over here. 1 added to 3 numbers should give you answer tens, the units place as 5 here. So that is possible only when B is 8, because if you choose B is 4, you get 4 plus 4 plus 4, that is 12. 12 added 1 to carry 1, you get 13. 13 has a 3 over here, but C is 5. So I don't get the first option. So the answer is the last option. Let us verify. 5 plus 5 plus 5 is 15. 1 carries over here. And if you add 3 B's, 3, 8 here, you get 24. 24 plus 1 is 25. So 5 comes over here. 2 carries over here. And if you choose A is 1, you get 3 here. 3 A's gives you 3. 2 carries over to give you 5 here. So the answer is 555. Upon choosing A is 1, B is 8, and C is 5. So you can check that if you add 185 3 times, you get 555. So that's the problem. So the answer is the fourth option. 185 is the correct answer. So a little bit of application of calculations will give you all these results. So it's not a big issue. For the next question, see, I'm a person who like numbers very much. So if you give me any question regarding numbers, I would immediately grab it and solve. And so that's one of the things that I like most, solving puzzles regarding numbers. If the product of three consecutive positive integers is equal to their sum, then what would be the sum of the squares? Now, if product of, you are given three positive integers, if that being the case, then the numbers should be 1, 2, and 3, because 1 plus 2 plus 3 is 6, and 1 times 2 times 3 is also 6. So the required number, unless you know this equation regarding numbers, you can't solve this problem very easily. If the question is asked for two numbers, if the product of two consecutive positive the product of two numbers is equal to the sum of the number, then the answer, not consecutive of course, then the answer would be 2 and 2. So 2 plus 2 is 2, 2 into 2 is also 2 plus 2 is 4, 2 times 2 is also 4. So if the problem is given for two numbers, positive number, then the answer is 2 and 2. Here it is given three consecutive positive integers, it should be 1, 2, and 3. Of course, if we try to solve this without knowing this equation, it's quite difficult and time consuming also. But we are fortunate to be given very small answer here. So the sum of the squares would be 1 square plus 2 square plus 3 square. That is the second option, 40. It's quite easy. If you are given the same problem with respect to 4 number, there is a solution for 4 number also. So if you are given the same problem with respect to 4 number, there is a solution for 4 number also.
Sir. Sir.
Sir, share option கொடுங்க sir.
Sir, நீங்க ஷேர் பண்ணுங்க sir. Again, you have to share one more time, sir.
Actually, எனக்கு இங்க அந்த பட்டன் ஆன் ஆகலையே.
அப்படிங்களா சார்? Again, you have to share, sir.
Your screen share பண்ணிட்டேன். ஷேர் பண்ண ஸ்கிரீன் இங்க இது வந்தாதுன்னு ஆன் ஆகும்ல?
ஆமாங்க சார். எங்களுக்கு உங்க ஸ்கிரீன் விசிபிளா இல்லைங்க சார். நீங்க ஷேர் பண்ணதுக்கு அப்புறம் தான் நான் அதுல இன்க்ளூட் பண்ண முடியும் சார்.
இப்போ தெரியுதா சார்?
இல்லைங்க சார். இப்போ வரலைங்க சார்.
ஸ்கிரீன் தெரியுதா?
இல்ல சார், ஷேர் ஆகல சார்.
அதான் சார், எனக்கு இங்க ஷேர்னு இங்க இது ஓபன் ஆகணும் சார், அப்பதான் வரும் அது.
ஆமாங்க சார்.
எனக்கு அந்த பட்டன் முதல்ல இருந்தே வர மாட்டேங்குது
சார். மிடில்ல ஷேர் ஸ்கிரீன் ஒரு ஆப்ஷன் இருக்கும் சார். அந்த
இல்ல சார், அதுதான் நான் பண்ணிட்டேன். ஷேர் ஸ்கிரீன் பண்ணிட்டேன், ஓபன் ஆயிடுச்சு எனக்கு. பட் இங்க வரலையே எனக்கு. இங்கே ஒரு இது மாதிரி வரும் சார். இங்க ப்ளூ கலர்ல எனக்கு அது ஆன் ஆகணும் ஷேர் அப்படின்னு, அப்பதான் வரும். அது நீங்க அப்ப ஆன் பண்ணீங்க அது?
எஸ் சார். ஸ்கிரீன் ஷேர் ஆச்சுங்க சார். இப்போ ஆகலைங்க சார். சார் க்ளோஸ் பண்ணிட்டு ஒன் மோர் டைம் ட்ரை பண்ணுங்க சார். ஸ்கிரீன் ஷேர் என்டையர் பிரசன்டேஷன் சார்.
சார் இன்னும் வரலையே சார் அது?
இல்ல வரலைங்க சார். ஸ்கிரீன் ஷேர் ஆகலைங்க சார். சார் அந்த பட்டன் ஒர்க் ஆகலைங்களா சார்? ஷேர் ஸ்கிரீன் பட்டன் சார்.
இல்ல, எனக்கு இங்க அந்த ப்ளூ கலர் இது வந்தாதான் ஷேர் பண்ண முடியும். நீங்க பண்ணணும்ல?
அதான் சார், எனக்கு உங்களோட ஸ்கிரீன் ஷேர் பண்ணிடுமா சார்? எனக்கு விசிபிள் ஆகலைங்க சார். சார் நீங்க க்ளோஸ் பண்ணிட்டு ஒன் மோர் டைம் ட்ரை பண்ணி பாருங்க சார். ஸ்கிரீன் ஷேர் ஆப்ஷன் மட்டும் சார். ஆக்சுவலா விசிபிள் ஆகலைங்க சார். சார் அதர்வைஸ் சார்
ஏன் ஷேர் ஆக மாட்டேங்குது
சார்? நீங்க லீவ் ஸ்டுடியோ கொடுத்துட்டு திரும்ப ஜாயின் பண்ணுங்க சார். அந்த ஆப்ஷன் திரும்ப ஸ்டார்டிங்ல இருந்து வருங்க சார். சப்போஸ் ஷேர் ஆயிருந்து ஏதாவது ப்ராப்ளம் இருக்கும் சார்.
இல்ல, ஏன் ஷேர் ஆகல எனக்கு புரியல எனக்கு. சார் இங்க ஸ்கிரீன் ஷேரிங் வாஸ் கேன்சல்ட்னு போட்டிருக்கு.
ஓகே ஓகே சார். அதான் சார், நீங்க திரும்ப அகைன் நீங்க திரும்ப ஷேர் பண்ணுங்க சார். அந்த பட்டன் ஒர்க் ஆகுங்களா சார்? ஸ்கிரீன் ஷேர் ஸ்கிரீன் பட்டன் சார். சார் பாட்டம்ல
PowerPoint ஓபன் பண்ணிக்குவா?
இல்லைங்க சார், ஃபர்ஸ்ட் ஷேர் ஸ்கிரீன் கொடுத்துருங்க சார். அதுக்கப்புறம் பிபிடி ஓபன். இல்லைங்க சார், உங்களுக்கு அந்த பட்டன் ஓபன் பாருங்க சார். சார் ஸ்ட்ரீம் யார்ட் உள்ள பாத்தீங்கன்னா 6 பட்டன்ஸ் இருக்கு இல்லைங்களா சார்? அதுல மிடில்ல இருக்க ஐகான் பாத்தீங்கன்னா ஷேர் ஸ்கிரீன் சார்.
இல்ல, ஷேர் ஸ்கிரீன்லாம் வந்துருச்சு சார். நான் ஷேர்னு போட்டா எனக்கு இங்க ஆன் ஆக மாட்டேங்குது. அந்த ஆப்ஷனே வரல. நீங்க எனக்கு அது இது பண்ணாதான் எனக்கு இங்க ஆன் ஆகும். அப்போ ப்ளூ கலர்ல வந்தது. அது இது பண்ணும்போது உள்ள போயிடுச்சு. அது எனக்கு அது ஆக்டிவேட் ஆகல.
உங்களோட ஸ்கிரீன் எங்களுக்கு விசிபிள் ஆச்சுன்னா நாங்க ஸ்க்ரீன் அது உள்ள கொண்டு வந்துருவோங்க சார். எங்களுக்கு விசிபிள்
என்
ஆகல சார்.
ஸ்கிரீன் இருக்கா உங்களுக்கு?
இல்ல சார், ஸ்க்ரீன் இல்லைங்க சார். உங்க ஸ்க்ரீன் எனக்கு விசிபிள் ஆச்சுன்னா தான் நான் உள்ள கொண்டு வர முடியுங்க சார்.
இல்ல இப்போ என் ஸ்கிரீன் தெரியுதா பாருங்க.
இல்ல சார், விசிபிளா இல்லைங்க சார். சார்
சார் ஷேர் ஆப்ஷனை கிளிக் ஆகலையே சார். இப்போ என்ன பண்ணலாம்? சரி, ஷேர் ஸ்க்ரீன் காமிச்சோம்னா அந்த சின்ன டயலாக் பாக்ஸ் மாதிரி வருது. இவர் என்டையர் ஸ்க்ரீன் காமிக்குது. அதுல போய் ஷேரை நான் கிளிக் பண்ணா வர மாட்டேங்குது. அது ஒண்ணுமே ஆக்டிவேட் ஆகலையே. ஆமா, அப்ளிகேஷன் விண்டோ குரோம் டேப் இருக்கு. ஆமா ஆமா ஆ ஆ ஆமா 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 ஆமா. ஓகே. Hello,
Sir,
is it visible now?
Yes sir, now visible sir. I will add your screen sir.
I apologize
Yes, sir.
for this technical problem. I don't
Okay
know.
sir. Sir, first
Shall I
slide.
start from the beginning then?
Yes sir.
Okay, so the first question.
Okay. Thank you, sir.
Shall I begin from the first question, sir?
Yes sir.
Okay. So there are three numbers of the form ABC adding up to the number of the form CCC. Now, if you take this three numbers here, adding three C's in the unit digit is also a C over here, which means there are two possible cases for C. C can either be 0 or 5, because adding three zeros you get 0 in the units place, or adding three fives you get 5 in the units place. No other digit apart from 0 and 5 will have this possibility. For example, if you add three twos, you don't get a 2 in the units digit, you get 6. If you add three threes, you get 9, so you get a different digit. So but C0 is not given in any of the option. Knowing that it's a single option question, I can conclude that the right answer is either the first option or the last option. So either the answer should be 345 or 185. Now going forward, if I choose C is 5, knowing that C is 5, I can add 5 3 times to get 15. So 1 is carry over here. 3 B's added to 1 gives you 5. So because C is 5, I know that the answer should be 5. And then again, there are two possible cases over here, because if you this carry is 1 here, if you add 3 times B, you should get the answer as 5. In that case, if the answer is 4, suppose if the answer is first option 4, if B is 4, you're adding 4 3 times, you get 12. 12 added to 1 gives you 13. So this cannot be 5 over here. So that is not the correct answer. B should be 8, because if you add 8 3 times, you get 24. Already 1 is carried over here. So 24 plus 1 is 25. So 2 is carried over here. And adding A, which is 1 here in this option, you get 3. 3 added to 2 gives you 5. So you can check that 185 added 3 times, you get 555. So the answer is the last option, fourth option, 185. So a little bit of application of carrying the digits and choosing the appropriate digits will give you this particular answer. Going forward to the next question, the product of three consecutive positive integers is equal to their sum. So what could be such numbers? Now, if the product of three consecutive integers is equal to their sum, then the number has to be 1, 2, and 3, because 1 plus 2 plus 3 is equal to 1 times 2 times 3. As I told you, if the same question was given instead of consecutive, if you are given the question like uh, product of two numbers is equal to their sum, then the number should be 2 and 2, because 2 times 2 is 4 and 2 plus 2 is also 4. If the same question is given for four numbers, then the choice of numbers should be 1, 1, 2, 4. 1 times 2 times 4 is same as 1 plus 1 plus 2 plus 4. So this kind of techniques will give you to guess the answer immediately. In this particular case, the numbers that we need are 1, 2, and 3, because 1 into 2 into 3 is 1 plus 2 plus 3. So knowing this idea, you can solve this problem. So the sum of their squares is 1 square plus 2 square plus 3 square, which is 14. The second option is the correct answer. Coming to the next question, the number of 4-digit numbers with no 2 digits common is, the four options are again given. Now, if the number is a 4-digit number, you have 10 possible digits from 0 to 9 to fill such numbers. Now, the leading digit, the first thousandth digit A, if the number is of the form ABCD, let us assume, then the 1000 digit A cannot be a 0. So, among the 10 possible digits, to fill the 1000 digit you can't take 0. So, there are 9 possible digits that you can take. So, 1000 digits can be filled in 9 possible ways. You can choose one among the first 9 digits except 0, because if the leading digit is 0, it cannot be a 4-digit number. It will be a 3-digit number or 2-digit number or something. It can't be a 4-digit number. For filling the second digit, the 100th digit, there are again 9 possibilities, because you have already filled one, so you can't take that particular digit. Okay. So what you have to do is no 2 digits are common because of that condition. So the 100 digit cannot be the same as the 1000th digit. Again, there are 2 possible cases, 9 possible cases, because 0 can be included here. For example, my 4-digit number can be 4021, something like that. So the 100 digit can be 0. I have already chosen 1 out of 10 possible digits. So the other 100 possible digit is, there are 9 options. For the 10th digit, there are 8 options, because I have already chosen the 100 digit, so I can't choose that, as well as the 1000th digit. So for the filling up the 10th place, there are 8 possibilities. For filling up the 1st place, you have 7 possibilities. So the number of possible 4-digit numbers would amount to 9 times 9 times 8 times 7, which takes out to give you 4536, the first option. Now listen, this kind of simple calculations will give you this answers quite easily. All you have to do is apply the ideas correctly with basic things in numbers. Now here, net 14 and net 15 are 5-digit numbers, such that the sum is 157229. Then sum of n plus n, e, and t would be. Now this, if you add these two numbers, you get the answer as 157229. This 4 plus 5 gives you 9. 1 plus 1 gives you 2. So 14 plus 15 adds up to 29. There's no problem here. Now if you take the 3 leading digits, net and net here, this terms here, net and net, then what you have to do is you have to ensure the answer is 1572. Now coming to this digit t here, I have a digit t. When I add t 2 times, I should get 2 as the answer here. So adding identical digits, you get only an even number in the answer. Now if you add t and t twice and you get 2 here, then there are 2 possible cases for t. T can either be 1 or it can be 6, because 1 plus 1 is 2 or 6 plus 6 is 12. So you get 2 here and 1 gets carried out there. So t can either be 1 or 6. If suppose if t is 1, then 1 plus 1 is 2 here. Then in this case here, if you take the thousands digit here, e and e, if you add 2 e's, I should get 7. Suppose if t is 1, then e plus e should give me 7. Now here there is a problem because you see, sum of identical digits will always be even number. If you add, for example, if you add two even numbers, the answer is an even number. As well as if you add two odd numbers, the answer is again an even number. So you can't get an odd number upon adding two identical digits. In that case, what I have to do is, so t can't be 1, because if t is 1, e plus e can't be 7, can't end with 7. So that is a problem there. So t has to be 6, it can't be 1. So if I choose t is 6, then 6 plus 6 is 12, 1 gets carried over here, then 2 e's and 1 will add up to 7. And again, this case gives me two possibilities. E can either be 3 or 8, because if you add e, if you add 3 two times, you get 3 plus 3 is 6. 6 added up to 1 gives you 7. Suppose if e is 3, 3 plus 3 is 6. This carry over 1 will make you 7. But again, same problem occurs here. N plus n should add up to 15. As I told you, two identical digits upon adding will never give an odd number as answer. If you add two identical digits, sum is always even. Therefore, you can't get 15 here when you assume e is 3. This forces me to conclude that e to be 8. So 8 plus 8 is 16. This carry over 1 will gives you 17. So 1 gets carried over here. So 2 n's added up to 1 gives you 15. Therefore, n has to be 7, because 7 plus 7 is 14. Added up to 1, that gives you 15. So with this calculation, we found that n has to be 7, e has to be 8, and t has to be 6. So net comes to 786. The sum of this numbers, then this digits 7, 8, and 6 is 21, because 7 plus 8 plus 6 is 21. So the answer is the second option. Now for the next question here, a cylindrical cake is to be cut into 6 equal pieces. What is the minimum number of cuts required to do so? Now, those who know some bit of combinatorics and counting problems can solve immediately this. In fact, cutting cake problem is a huge literature in mathematics. There are many problems that has come out. There is a nice formula for cutting a cake with minimum number of cuts. The answer turns out to be triangular numbers plus 1. In particular, for having minimum of n cuts, the answer turns out to be n plus 1 c2 plus 1. That is n into n plus 1 by 2 plus 1. So the answer are the minimum number of cuts required to having cut a cake of any shape, not necessarily cylindrical. It can also be cubical shape. Any cake. If you cut this, then the minimum number of shapes has to be cuts has to be n plus 1 c2 plus 1. So in this case, the answer should be n plus 1 c2, which is n into n plus 1 by 2 plus 1 is 16. What is n? So n into n plus 1 by 2 should be 15, n should be 5. It's a quadratic equation you can easily solve. In fact, if you have time, you can go to Google and just type lazy Caterer sequence. There's a wonderful sequence describing this number of cuts of a cake with minimum number of cuts. The minimum number of cuts required for cutting cake efficiently turns out to be a sequence itself, and that sequence is called a lazy Caterer sequence. Caterer, lazy Caterer sequence. Go to Google and check yourself. So the answer should be, the answers for minimum number of cuts required for getting maximum number of pieces in a cake is triangular numbers plus 1. Remember, the numbers of the form n into n plus 1 by 2 are called triangular numbers. So the answer is triangular numbers plus 1. And 15 is a triangular number, the fifth triangular number. And adding that to 1, you get 16. So the answer is 5 here. So 5 minimum number of cuts is required to get 16 equal pieces. In fact, if you want to get equal pieces, the cake should be cylindrical cake. If you want to get unequal pieces, then it can be of any shape. The term cylindrical is given to ensure that the 16 pieces are all equal size. If you don't get equal, then the shape of the cake can be anything. So the same formula works, but the number of the pieces cannot be of different size. Okay. Now, for the 19th question, the next question. So the answer here is the fourth option, 5. For the 17th question, the answer is 5. Because fifth triangular number plus 1 gives you 60. How many different salads can be made from cucumber, tomatoes, onions, beetroots, and carrots? There are 5 different ingredients. In fact, there is a book written by Mahavira of in around 850 AD or 850 Common Era CE, which actually tells about this. In that particular book, Mahavira discusses about the basic idea of combinations and permutations. and that's the first official book to discuss mathematically about all these things. So what I need to do is the way to combine uh, how many possible subsets, treating this each fruit as, or each vegetable as an element. So I have a set with 5 elements like cucumber, tomato, onion, beetroot, and carrot. So 5 elements. How many subsets that you get for a set with 5 elements? I mean, number of possible subsets. That is a power set. And for a power set with n elements, for if a set has n elements, then the power set will have the cardinality of the power set will be 2 to the power n. If your given set has n elements, then the power set will have 2 to the power n elements. Therefore, I have a set with 5 ingredients. This 5 ingredients given in the question. So if I could possibly combine these 5 ingredients, I should get 2 power 5 possibility. That turns out to be 32, the fourth option. So this is even simple mathematics, but given as an application for real life problem. And this is a very small question, but just given for enjoying purpose. Sin A cos B plus cos A sin B is sin A plus B. Being a right triangle, one of the angle is a 90 degrees. So these two angles should add up to 90, because the sum of angles in a plane triangle should be 180 degrees. So A plus B is 90, and this is sin A plus B. So sin 90 is 1. Second option is correct. So there's nothing more you can involve. So if you look at all these answers here, if you just think a little bit quickly, you get this answers. It's important that you should not take much time. Not only there are two aspects in writing NET exam. One is that you should get the correct answer. The second is you cannot afford to take more time to spend more time in getting the answer. So you should be clever enough. That is why you need some practice in doing such problem. And the more you think, more ideas you get. Okay. In particular, as a clue to you, I would advise students to just take notes of whatever I am saying. In particular, for n numbers whose sum is equal to product, the concept is you take n minus 2 once and then take 1, 2, and the last number is n. So that gives you sum is equal to product for n numbers. If you know these ideas beforehand, you can possibly do this very quickly. Some of them, actually. Now, listen here. N is a 2-digit number such that the product of its digit when added to their sum equals n. In fact, those who are very familiar with basic characteristics of numbers can immediately guess that the answer is 9. Unit digit of 9, n should be 9. Because if you, for example, if you take 19, for example, product of digits of 19 is 1 times 9 is 9. And if you add the digits, you get 10. Now 1 plus 9 is 10. 19 plus 10 is 29. So you get the same units digit. And if you do this for any other options like 1 or 7 or 8, you can't get it. In fact, 9 is the only digit possessing this property. In fact, this property works for all 2-digit numbers beginning from 19, 29, 39, 49, up to 89, or even up to 99. So all these numbers will work if unit digit is 9. So the answer is the fourth option, 9. The other things cannot work. Okay. And here, because I can't write it possibly and show you, I have given the steps. For the first equation, you multiply by q, you get pq plus 1 is q. For the second equation, you multiply by r, you get qr plus 1 is r. And then for this q here, you substitute the first equation. Qr plus 1 is r. For the first term q, you substitute pq plus 1 here, the second equation from the first equation. For in the place of q, you substitute pq plus 1. So pq plus 1 into r plus 1 is r. That gives you pqr is minus 1. So it's a straightforward calculation. Nothing much is involved. And the next question, what's the remainder when 3 power 256 is divided by 5? So what I have to do is choose some power of 3, first smaller power of 3, which is as close as possible to multiple of 5. Because this is modular calculation. So you choose some power of 3, convenient power of 3 with smaller number here, so that it's very near to some multiple of 5. For example, 3 power 2, 3 square is 9, and 9 is very close to 10. 9 is in fact 1 less than 10. Therefore, I get this congruence first. 3 square is 9. 9 is congruent to minus 1 mod 5 because it's 1 less than multiple of 5. So 3 square is congruent to minus 1 mod 5. So 3 to the power 256 raising to the power 128. On the right hand side, I get minus 1 to the power 128. You know that minus 1 to the power odd number is minus 1, and minus 1 to the power any even number is plus 1. So minus 1 to the power 128 is plus 1. Therefore, 3 power 256 is congruent to 1 mod 5, which means when you divide 3 power 256 by 5, the remainder is 1. The first option is the correct answer. So for tackling all such problems, what you have to do is choose some convenient power of the given base, like 3 here, which is close to the multiple of the given number, whatever number you're dividing. Suppose if dividing by 7, you choose some lesser power of 3, which is close to multiple of 7. Suppose if the same question is asked for divided by 7, you could possibly choose any number, I mean power of 3, which is very, very close to multiple of 7, not multiple of 5. So whatever you choose, and there are some good theorems that you can find here. There are two important theorems that you can use here for not all the problem, but most of the problems of this sort. You can use Fermat's Little's theorem, which is a to the power of p is congruent to a mod p whenever a and p are co-prime. Or you can also use Euler's theorem, which is a to the power phi of n is congruent to 1 mod n. So this kind of theorem will help you. That is more general than the Fermat's theorem. So you can use this kind of theorems to tackle this question, but common sense will lead you to this answer. So it's not very difficult as you think. Okay. Now, these are all section A questions that I completed now. Now we'll see some of the questions from section B. Again, these are single option questions, but they are from real analysis topic. These questions are from general type, covering all basic branches of mathematics. But now we'll discuss single option questions from real analysis. Let A be set of all x square such that x is between 0 to 1, and B be set of all x cube such that x is between 1 to 2. If you choose this way, then you see that A is your set which is 0, 1, because 0 square is 0 and 1 square is 1. So A is open interval 0, 1, and B, you see 1 cube is 1 and 2 cube is 8. So B is open, and because it is given that x lies between 0, 1 and x lies between 0, 2, the set A and B will be in the open interval. It is not a closed interval. So A is open interval 0, 1 and B is open interval 1, 8, because 2 cube is 8. So can you define a function which is say 1, 1 on 2, or 1, 1 but not on 2, some of all these things? In fact, I can tell you there is a wonderful theorem in analysis, real analysis, saying that any two intervals, identical intervals, so any two open intervals are isomorphic and any two closed intervals are isomorphic. Between any two identical intervals, like open to open or closed to closed, you can always define a bijection, which means it's always possible to define a 1, 1 on 2 function. In that sense, the answer is the first option. Because this is an open interval of the form 0, 1, and this is an open interval of the form 1, 8. It is always possible for me to define a 1, 1 on 2 function between the open interval 0, 1 to the open interval 1, 8. So this is the idea. In fact, such a function, if you can note it down, would be f of x is 7x plus 1. But how do I guess it? If you take f of x is 7x plus 1, then that will be certainly a 1, 1 on 2 function from A to B. But how did I possibly guess it? See, I have a set like 0, 1 and one set, and other set domain is 0, 1 and codomain is 1, 8. So what you choose is choose x1 as 0, x2 as 1. Like I have 2 points here, 0, 1 and 1, 8. Choose the first point as coordinates. The first point as x1, y1. Choose the second one as x2, y2. You take a line segment joining these 2 points. That gives you the answer. So the line segment joining 2 points is y minus y2 by y minus y1 by y2 minus y1 is x minus x1 by x2 minus x1. 2-point form. If you take 2-point form of the line joining 2 points with coordinates x1, y1, x2, y2, then you get this answer. If you work out, you get 7x plus 1. That's as simple as that. It's a linear function. So that will give you 1, 1 on 2 between A and B. But the basic fact, you need not have to work it out. For the sake of understanding, I'm giving the function explicitly, but there's no need to work out for the function. If you know the fact that in most of the questions in analysis, if you know the concerned theorem, you can immediately guess the answer in most of the cases. You do not have to explicitly mention here. That is not required in the question. So any two intervals are isomorphic, or homeomorphic. In that sense, which means both f and f inverse are continuous. So not only f will be continuous, f inverse will also be continuous, and therefore it is certainly possible for me to define a 1, 1 on 2 function between these two sets. The answer is the first option. And if you take the next question, limit n tends to infinity, this formula is very important, especially students who pursue net exam. Please note down this formula. This is called the Euler's limit. Because of the importance of the formula, I have myself written this here through equation, because I can't tell this in the words, and even if I do that, you can't understand possibly. So 1 plus a by n plus power to the power bn plus c, where a, b, c are real numbers, tends to e to the power ab. So immaterial of what happens to this c, that c is not important to me. This a multiplied with this coefficient of n, which is b, gives the answer. So that's e to the power ab. This is called Euler's limit, named after in the honor of Euler, who gave these formulas. So if you use this formula here, see 1 minus 1 by n squared to the power n, this 1 minus 1 by n squared can be factorized as 1 minus 1 by n times 1 plus 1 by n. So as limit n tends to infinity, here a is minus 1, b is plus 1. If you see this particular formula here, the first factor a is minus 1, b is plus 1, so the answer is e power ab, that is e power minus 1. Here is a is plus 1, b is plus 1, so the answer is e power ab, that is e to the power 1, and upon multiplying this you get 1, so the answer is clearly the first option. So if you know all these facts, the Euler's limit here, you get this answer. See, in most of the cases, either if you know the appropriate formula or if you know the appropriate theorem, you get the answers within no time. But you have to possibly, you have so many formulas as tools with you, you have to possibly choose which formula that you require to apply for which problem. If you have this enough practice with you, you can easily crack almost all the problems in real analysis, except a few questions which are a little difficult and involved. But most of the questions are straightforward like this, if you know the appropriate theorems and formulas. Consider the interval minus 1 comma plus 1 and a sequence an of elements in it. Then again, see, if you take any point in the given interval of sequence of points, that point obviously happens to be a limit point. For example, if I take half in this interval, which half is a point in this interval, I can define sequence an as half, half, half of any constant sequence converges to the same value. Therefore, half, 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 half will converge to half. In this particular idea is applicable to any point in this inside this interval minus 1 comma plus 1, not just for half. If you take 0, I can define a sequence as 0, 0, 0, 0, which converges to 0. So obviously that is a limit point. So there's nothing interesting in choosing a point inside the interval, but things become tricky when you take the endpoints. See, when you're concerned with questions regarding limit points, you always choose the endpoint, because that is where you get some problem. That is the point of investigation that you need to consider. If at all you need to consider something regarding limit points, you have to take the endpoints. So I have to possibly see whether if I can define a sequence an such that minus 1 is a limit point as well as plus 1 is a limit point. If minus 1 as well as plus 1 is a limit point, then the answer is the second option. If that is not the case, then the answer is the first option. Third and fourth will not be correct. Okay, because as I told you, limit points of an can only be minus 1, 0, 1. That is incorrect, because any point inside the interval minus 1 plus 1 is also a limit point. So that is not a correct. So 3 and 4 are incorrect options. So this is again a single option question. So answer is either the first option or the second option. Now, in particular, I had worked it out with my experience. I found that if you take this sequence here, I leave this as an exercise to you for the students. If you take an as minus 1 power n times into minus 1 power n into n by n plus 1, minus 1 power n into n by n plus 1. If you take this particular sequence, you see that this oscillates between minus 1 to plus 1 indefinitely. It will never converge neither to minus 1 nor to plus 1. So neither minus 1 nor plus 1 is a limit point for this. Therefore, the answer is first option, because minus 1 comma plus 1 cannot be limit point for every sequence, possible sequence. Okay. In particular, it is not a limit point for the particular sequence that I told you, which is minus 1 power n into n by n plus 1. So the answer is the first option. Let f from R to R be a monotone function. So monotone function is either an increasing function or a decreasing function, but not both. It should possess only one among these two characters. Like e to the power x is a monotone function because it's increasing completely. Or if you take e to the power of minus x, it's a decreasing function. So that is a decreasing monotone function. So mono means one, only exhibiting only one character. Either in the given interval or in the given domain, it should completely be increasing, or it should be completely be decreasing. Some book may write non-decreasing or non-increasing. That's different. See, if you say non-decreasing, it should not come down. It should either maintain its same value or it should increase between the points. It should not decrease at any point. Same thing for non-increasing. Now, if you assume that f is a monotone function, then f has no discontinuities, all this. If you are familiar with the ideas in probability theory, your distribution function capital F. In fact, the main idea of giving this question as capital F instead of usually small f is because you have to correlate this to the distribution function that you come across in probability cases. In probability case, you see the distribution function is a non-decreasing function, right? Continuous, and the number of discontinuities can be at most countable. In fact, I have given an example here to justify this. This is the greatest integer function. If you take this function, this is a monotone function. It's a non-decreasing function. Either it remains constant or it increases, but at no point it decreases. So it's a non-decreasing function. Okay. See, there's a difference between non-decreasing and increasing. Like functions like e power x is an increasing function, whereas this is a non-decrease, because in the interval of unit length, you see from -3 to -2 here, the function takes the same value, namely -3. It takes the same value, but once it touches -2, it jumps over here. So it's a step function or greatest integer function, and you see the function gets broken at every integer point. So when you come across this way, it gets broken and jumping here, and then it gets broken and jumping here. It gets broken and jumping here. So it has discontinuities of jump type. In fact, it's the right continuous function, and therefore the number of discontinuities is infinitely many here. In fact, it's countably many, because the set of you see that the discontinuities occurs at integer points, and set of integers are countable, and therefore this particular function have at the most countable discontinuities. You can even have finite discontinuities, but countable discontinuities is the most general answer. See, any finite set of course is countable, but the more general answer is it will have not only have finitely. See, f has only finitely many discontinuities is incorrect, because I can give a function which has infinitely many discontinuities. So the correct answer should be the third option. F can have at most countably many discontinuities. F cannot have uncountably many discontinuities. It is the third option is the correct. And this option, in fact, we prove this as a theorem for a distribution function. The number of discontinuities of a distribution function is at most countable. This is a very famous theorem in probability theory. Okay. So the idea comes from there. That is why they have given capital F instead of small f. Okay. So maybe I can. I have given this function. It's a floor function, which is also called greatest integer function. So as far as possible, I try to plot the graphs also for better understanding. So consider the improper Riemann integral 0 to x y to the power of -12 dy. Now, if you calculate, this is an easy question, because if you integrate this, you get y power -12 plus 1 by -12 plus 1, and apply the limit, you get the answer as 2 times root x. If you apply the limits here, because upper limit is x, you get answer as function of x. So you get the answer as 2 root x, and 2 root x has this particular graph. See, root x is continuous in the interval from 0 to infinity, close to this interval, this closed interval 0 to infinity. So you see, this is a graph of 2 root x, and this is continuous. In fact, root x is continuous whenever x is greater than or equal to 0. So 2 root x is also continuous whenever x is greater than or equal to 0. So the second option is very close to the first option, but unfortunately it is incorrect, because the function 2 root x is also continuous at 0, but it is given as continuous only in open intervals 0, infinity. So that is incorrect. Other things are of course not correct. The answer is first option, continuous in the interval, closed interval 0, infinity. Now listen, consider the function f of xy is x squared by y square for all xy belonging to this Cartesian product here. Now listen, x takes numbers in this and y takes numbers in this. This is a rectangle here. In fact, this is a square in fact here. Now if you, it's a rectangle. if you take the derivative of the function, the derivative here is the directional derivative, because you are asked to find the derivative of the function along this direction. And you have a simple nice formula. The directional derivative of function in the given direction is del f dot the vector in the given direction, unit vector particularly. But in this answers, I found that they have not considered unit vector. Okay, so the vector in the given direction 1 comma 1 is I plus j. If you want, you can just note it down and check it later. The vector in the given direction is 1 into I plus 1 into j, which is I plus j. The derivative of the function at 1 comma 1 is del f. So you find dou f by dou x and multiply that by I, and find dou f by dou y and multiply that by j. Here dou f by dou x is 2x by y square. If you substitute 1 comma 1, you get 2i, and dou f by dou y happens to be minus 2x square by y cube, and if you substitute 1 comma 1, you get minus 2j because of the negative sign upon differentiating. So del f at 1 comma 1 will turn out to be 2i minus 2j, and in the direction of the given vector here is I plus j. So if you take the dot product of these two, you get 2 minus 2, you get 0. So first option is the correct answer. So simple problem. This comes in vector calculus in your second year course of BSc, so it's not a difficult thing to do. Consider the sets of sequences. Capital X is set of all xn such that xn belongs to 0, 1. So xn is either 0 or 1, where n is a natural number, and y is set of all sequences such that xn is 1 for at most finitely many. So this is somewhat a tricky question. You need to think more. You can't just go it off. Now, if you say that xn is either 0 or 1 and take capital X as sequences with zeros and ones, there are uncountably many possibilities that you have, because 0 can be placed anywhere. The sequence is set an infinite set, isn't it? So it goes up to as n tends to infinity. So you see, you can have infinite numbers with zeros and ones, and the zeros, locations of zeros and ones are not at all, you can't place it anywhere. You can, there's no rule to place possibly where 0 should come, where 1 should come. You can take all zeros or ones, or insert 0 between 2 ones, or insert 0 between 3 ones, and or insert between 0 and anywhere as you like. So this collection will be uncountable. This X is uncountable because you can't order it properly. So anything that you can't make an ordering is not countable. So X is uncountable, whereas this is countable. Y is countable because you know that xn is 1 for at most finitely many n. So y contains, for example, elements like 1, 0, then first element is 1, and then all the rest is 0. Then the second element of y is 2 elements is 1, 1 comma 1, then the rest of all is 0. So I can give a bijection between set of natural numbers and this particular set y, making it countable. How do I give that? So for the first element 1 and the rest element 0, I can give, like, I can define a function f of k is set of all xk for which you have k ones. F of k is set of all xk in y such that it has k ones. So f of 1 is x1 because x1 has only 1 ones. Similarly, you can define such things and then enumerate. The enumeration of natural numbers to y is always possible, and therefore that makes y countable, whereas x is uncountable because you can place zeros and ones arbitrarily as you like. So x cannot be countable. X is uncountable, y should be countable. This is the answer, second option. And this problem is done usually when you know limit of summation as integration. See, one of the basic definition of integration is viewing it as limit of sum. So what you can do is write this 1 by n to the power of 4 as 1 by n time, bring this n cube inside the summation, because summation is only for j. So I can write this as 1 by n and bring this n cube inside. So j cube by n cube, you can write it as j by n whole cube. And because the power is, we are summing up to 2n minus 1, the j sums up to only odd numbers, which means there are 2 gaps in the interval that you take. So when you put n is 1 here, you get 1. When you put n is 2, you get 3. When you put n is 3, you get 5. So only odd numbers is what you have to sum up here, because there are 2 gaps. This will j by n you take as x. So limit of sum formula will turn this particular limit of sum to an integral of the form integral 0 to 2, because lower limit of j is 0, x is j by n. So when j is 0, x is 0. When j is 2n minus 1, you get 2n minus 1 by n, which is 2 minus 1 by n. As n tends to infinity, that goes to 2, because 1 by n goes to 0. So this goes to integral 0 to 2 x cube dx, because you see j cube by n cube, that is x, so x cube dx. And integrating x cube, you get x to the power of 4 by 4. The limits of the integration are 0 to 2. So if you substitute the upper limit and lower limit, you get 2 power 4 by 4, which is 16 by 4. The answer is first option, 4. It's quite easy to do if you know all these things. For this, I can't mention this problem, the solution of this problem through words as I did for the previous one. So for the sake of better understanding, I have written this as an equation. Listen, df by dx is less than or equal to 5 for all x, which means modulus of f dash of x is less than or equal to 5. This is derivative of f, first derivative of f. So that I can rewrite as modulus of, f dash of x is between minus 5 to 5. Here modulus of f dash of x is less than or equal to 5, which means that f dash of x should lie in the interval minus 5 to 5. Integrate on all sides of this equation, because you know from Riemann integral that if f is less than or equal to g, then integral f is less than or equal to integral g, the monotonic property of the integrals. Now, if you integrate this from 0 to 1, because I choose 0 to 1 because for a purpose here, because I am given f of 0 here, that is 0 in the question. I'm asked to find f of 1. So 0 is given, 1 is needed. Therefore, I choose the interval of the limits of the integration as 0 to 1. Upon integrating, you find that minus 5 integral dx is x. You substitute the limit, you get this one, and for this one, you get 5 over here. For this, using fundamental theorem of calculus, integral of f dash of x turns out to be f of x. And if you apply the limits here, you get upper limit is f of 1, lower limit is f of 0. This is because of the fundamental theorem of calculus. So you get minus 5 less than or equal to f of 1 minus f of 0 less than or equal to 5. Because f of 0 is 0, I can substitute that here. So you get f of 1 between minus 5 to plus 5. So the answer is, I'm asked to find the range for f of 1. So f of 1 lies between minus 5 to plus 5, the closed interval. Therefore, the answer is second option. So it's quite straightforward application of the properties of integral and using fundamental theorem of calculus. And this problem, I leave it as an exercise to students. The answer is second option. It's quite easy to see, because if you differentiate dou f by dou x is, that is y, dou f by dou y is x, and if you substitute this point, calculate del f at this point, and then the vector in this direction, say at this point, of course, in the dash derivative of v at the point a. So if you find del f at this point, a1, a2, you get a2i plus a1j, and if you multiply that with the vector in this direction of v, which is I plus 2j, you get second option. You can just work out the details of this and get this answer. It's del f. We have done a similar problem earlier, so you can use that idea to do this particular problem. Now here, let fn of x is minus x to the power n wherever x belongs to 0, 1. Then decide which of the following are true. There exists a pointwise convergence subsequence of fn. Fn has no pointwise convergence subsequence. Fn, if you know there are particular theorems to guess this answers immediately. But anyway, for the sake of better understanding, I'm not using the theorem here, but because you may not have the practice or experience to do that. In particular, see, I always prefer giving examples. You can choose any x belonging to 0, 1. So if you choose possibly x is half or any number in this interval 0 to 1, particularly if I choose half x, because you are asked to find there exists a, which means even if you give a single example, this is correct. So if I choose x is half here, you get minus half to the power n, and that converges to 0. 0 is in the interval, so minus half to the power n converges to 0. In fact, for any x in 0, 1, that converges to 0, but for 1, except 1, for all numbers. So, but again, I told you, it's enough to just give one particular value of x. So if you choose x is half or 1/3 or 1/4, which is any number of x, value of x which is strictly less than 1, that will converge pointwise to the given subsequence of f, and therefore the answer is the first option. You can just see, in some cases, if you don't have any idea behind how to do, You just take particular cases and work out. If the things work out for 2 or 3 particular cases, especially in the net exam, it can't be done in the main exam, semester exam, where you need to prove main theorems. But for doing problems in net exam, in many cases, if it is not accessible directly to you, or if you don't have any clue with you, the basic idea is to just substitute, pick some particular cases and see how it works, get some pattern behind it, and then you can conclude the answer. That is one of the possible way to do, in case if you don't have any idea about how to proceed. Now, this problem is a wonderful problem. In fact, out of all, when I wrote the solutions for all this problem that I'm discussing, I took more time in solving this problem. This is a problem that took some time for me to guess. The other things I guessed some in very less time, but this one consumed somewhat larger time for me. But anyway, somehow I got the answer, possibly. Now, one thing, if you are asked to find limit of 1 by nth root of n factorial, one thing is that I can use a principle called skews principle or sandwich property, or whatever you call, because this is sandwiched between these two sequences. Okay, so this is greater than or equal to 1. You can read details. I have worked it, and this is also less than or equal to 1 by n. Is sandwich to 0, this goes to 0. So limit of this lies between 0 to 0, therefore it has to be 0. This is one possible way. In fact, I worked out the answer in 3 possible ways. This is by using squeeze principle, but unless you get enough practice, you can't guess this inequality. It's quite difficult. So for those who want to do the other way, which if you are not able to guess this by this way, what you can possibly do is take log on both sides, because L is given to be this. Take logarithm on both sides and simplify. You get some expression like log L is minus of log of n factorial by n. Because I have worked it out, I know the steps, and that term goes to infinity, and therefore you get log L is minus infinity. So L becomes e to the power of minus infinity, which is 0. So that's how it's worked out. So there's another way also. Instead of using this inequality or this particular theorem, you can also use that particular property to get this answer. Now for the next example, consider the sequence an is 1 plus minus 1 power n into 1 by n to the power n. Now if you remember the Euler's limit that I told you, 1 plus a by n power n, but those numbers a and b are real number. They are constant. They don't depend on n. But this quantity is having n over here, so I can't use Euler's limit here, because if I need to use Euler's limit, this coefficient of 1 by n should be a constant. 1 plus a by n power b n. But b is 1 here, that is constant, but this is not a constant. But if you look at the answers, you are given supremum and infimum here. So you see, I know answer for this number, but what is minus 1 to the power n? So this is where I get, this is the point where we need to concentrate. This is a term of concentration. So minus 1 power n has supremum 1 when n is even, and minus 1 power n has infimum, which is minus 1 if n is odd. You all possibly know that minus 1 power n takes only 2 values whenever n is an integer. In particular, if n is even integer, you get plus 1, and if n is an odd integer, you get minus 1. Therefore, the supremum of minus 1 power n is plus 1 if n is even, and infimum of minus 1 power n is minus 1 if n is odd. In the case when you take supremum of limit of supremum of an, what you get is this becomes 1. So you get 1 plus 1 by n power n. In that case, you get the limit as e by Euler's answer. So supremum of an is e, you see here. So your answer is either the second option or the fourth option. Supremum of an is, because this happens to be 1. When you take supremum, this is 1. So you get 1 plus 1 by n power n. Taking the limit by Euler's limit, then it becomes e, because you get a is 1, b is 1. Therefore, e power ab multiplies to e power 1, e. If you take infimum of minus 1 to the power n, that is minus 1, because infimum of minus 1 power n is minus 1. As I told you, whenever that occurs whenever n is odd. And therefore, in that case, infimum of an becomes 1 minus 1 by n power n. We have already done this expression here. If you look at this, 1 plus 1 by n to the power n and 1 minus 1 by n to the power n. So this, for that particular sequence, this is the supremum and this is the infimum. This limit is e to the power of minus 1. This limit is e to the power of plus 1 by Euler's limit e power ab, okay, whenever n approaches infinity. So infimum of an is 1 minus 1 by n power n, which I know by Euler's limit is e to the power of minus 1, that is 1 by e. So this can't be the answer. Okay. So supremum of an is e for this particular sequence, and infimum of an is 1 by e. And you also note that infimum is less than or equal to supremum. In particular, if infimum value is strictly less than the supremum value, the sequence will not converge. It will converge only if infimum is equal to supremum. In this case, infimum turns out to be 1 by e and supremum turns out to be e. So infimum is strictly less than the supremum. Therefore, limit of an does not exist. Okay, so that's one thing that you can guess. And this is another very tricky problem that you come across. This is a not straightforward problem. So for a greater than 0, the series summation n1 to infinity a to the power of log n is convergent if and only if. So one thing that you can see here is, if you take a is e, for example, listen, if you take a is particularly e, what I can do is, because it's a summation problem, for convergence of series, you can use any one of the standard results like ratio test or comparison test or root test. In particular, the power is involving n, you can use root test. Because the power is involving logarithmic term, I possibly prefer to choose ratio test. So divide n plus first term by nth term of the given series. You, upon simplifying, I just give the simplified version. You get a to the power of ln of logarithm to the base e of 1 plus 1 by n. Now, if a is strictly less than 1 by e, then this will be strictly less than this, and therefore this goes to 0 as n tends to infinity. Therefore, this is less than 1. And by ratio test, you know, if limit of n plus first term by nth term, in particular limit of an plus 1 by a, supremum of that is less than 1, then the series converges absolutely. Otherwise, if it is greater than 1, it diverges. And if it is equal to 1, then the ratio test can't give the answer. The test fails. This is the thing that you learn in your college. Now listen. If what happens if a is e, actually e or 1 by e. If a is e here, you get e power log n, and e power log n is n. So summation n is divergent. It will not be convergent. So a can't be e. So if you go beyond 1 by e, this becomes the divergent sequence. So the answer is either the third option or the fourth option. It can't be this way, because if a is closer to e, this is divergent, because e to the power of log n is n, and summation n is divergent, because the nth term of n is non-zero. If the nth term of a series is non-zero, then it cannot converge. Okay. So if you take this possibilities here, either third or fourth. In particular, if the fourth answer is the correct one, then I can choose the difference between these two options only including a as 1 by e. So I can, if the fourth option is correct, this also works for a upon choosing 1 by e. What happens if you choose a is 1 by e here? If a is 1 by e, then that is e to the power of minus 1. That is e to the power of minus log n, which is e to the power of log 1 by n. E to the power of log 1 by n is simply 1 by n, and summation 1 by n is divergent because that is harmonic series. Summation 1 by n diverges. That's a very famous result. And therefore, if you choose a is 1 by e, this series also diverges. It is not convergent. Therefore, the correct option is the third option. A greater than 0 and but strictly less than 1 by e. If a is 1 by e, then this particular series diverges because it becomes a harmonic series. So it is not convergent. So this kind of, see, for doing this particular problem, I use so many ideas. Like I use ratio test, I use harmonic series divergence, I use so many things. That's why it is important for you to know all the boundaries and all the possible results that are available in linear analysis. And not only for instance, if you do a problem in algebra, or if you do a problem in some other subject like complex analysis or something, you have to be thorough in all the formulas. It's just like there are so many formulas, just like so many tools available for a mechanic. If a mechanic sees through some difficulty in some machine, he should appropriately choose the correct tool to rectify the machine. And therefore, just like solving a problem in net exams, just like choosing the correct tool. because there are so many formulas and theorems that are available. You have to choose appropriate thing, and only for that you need some practice. So this examples and idea that we discuss in net classes subsequently in C4 will help you to motivate and think like this in the similar lines when you yourself attempt in future. So this kind of experience is what you should gain in attending these classes. Okay, so that's the main reason for attending these classes, the motivation that you get. Now listen, f of x is sin x by x if x is non-zero, 1 if x is 0. So limit of f of x when you take x tends to 0, sin x by x goes to 1, that is equal to f of 0, so f is continuous. So the first option is not correct, because limit of f of x as x approaches to 0 is 1, because limit of sin x by x is 1 as x tends to 0, and f of 0 is also given to be 1. So in fact x is 0 is removable discontinuity of f here. So f is continuous, so the first option is incorrect. And then if you look at this here, second option, f is continuous but not differentiable. I need to check it. So let me check whether it's differentiable. Okay, so f dash of 0 by formulas limit x tends to 0, f of x minus f of 0 by x minus 0, applying derivative definition at the point x tends to at the point 0 here. So limit x tends to 0, sin x by x, f of x is sin x by x whenever x approaches to 0. F of 0 is 1, x minus 0 is x. So if you do this, you get this equation. Now sin x by Maclaurin series formula is x minus x cubed by 3 factorial plus x to the power of 5 by 5 factorial and all those things. If you substitute sin x as x minus x cubed by 3 factorial plus x power 5 by 5 factorial, subtract from x, that leading term x gets cancelled out. So the remaining term you get x cubed by 3 minus x cubed by 3 factorial plus x power 5 by 5 factorial and all those things. Upon dividing by x square, you get one term x in the numerator. The numerator will be of the form x by 3 minus x by 3 factorial plus x power x cubed by 5 factorial and all those things. If you substitute the limit as x tends to 0, you get 0, because when you divide by x square, all the terms will in the resulting expression will contain x. So whenever x approaches to 0, you get 0. So f dash of 0 is 0, therefore f is differentiable at 0, and for the derivative is 0 at the point x is equal to 0. Therefore the answer is third option. Because a single option question, f is differentiable is the correct answer. The third option is the correct option. Now here, let f from R to R be a continuous function, and f of x plus 1 is f of x for all x. See, if you say f of x, x plus 1 is equal to f of x, then if I substitute f of 0 here, I get, if I substitute x is 0 here, I get f of 1 is equal to f of 0. So if you assume f of 0 is k, for example, then f of 1 is also k. If I substitute x is 1 here, then f of 1 is equal to f of 2, that is also k, because f of 1 is already k. So if you substitute x is 0, 1, 2, 3 successively and use this equation here, this is called a functional equation. If you use this functional equation, you find that f of 0 is k, f of 1 is k, f of 2 is k, f of 3 is k. In fact, f of x is k for any real number x by the same argument. So any function satisfying this particular equation will be a constant function. And you know about constant function. What are the constants? This is, of course, we are now coming to multiple option questions. The single option questions I have completed. We'll discuss few multiple option questions. See, this is from section C part. Okay, section C part, multiple option. This is constant function. I haven't seen before. So this single option questions are over. We'll discuss few multiple option questions in the remaining time before we finish off this session. F of x is constant. Is the required function here. Any constant function will be bounded, because f of x is k, so f is bounded above and below, and f attains its bound. So third option is correct. If any constant function is a bounded function, it will attain its bound at all points here. And any constant function is not only continuous, it's also uniformly continuous. So I will discuss about uniformly continuous a little bit later with some other examples also. So any constant function is not only continuous, it's uniformly continuous. Therefore, the answer is third and fourth option. And this, for this particular problem, this is actually a more general problem is available here. If you take x1 is 0, x2 is 1, and if you take for n greater than or equal to 3, if you define xn as arithmetic mean, you see xn minus 1 plus xn minus 2 by 2. This is arithmetic mean of the two previous terms. Xn minus 1 and xn minus 2 are two previous terms to xn. So xn is defined as arithmetic mean of two previous terms. If you actually substitute this numbers x1, x2, and find x3 here, and using x2 and x3 if you find x4, and if using x3, x4 if you find x5, if you keep on doing that, you see the odd subscript and even subscript form non-increasing and non-decreasing sequence. So they converge to a point. They converge to a point, but they form two different sequences. Odd subscript and even subscript will be, one will be non-decreasing, the other will be non-increasing. So they converge to the same point. In fact, there is a wonderful general problem here which we actually do for taking net classes and jam classes. If you assume x1 is a and x2 is b, not just 0 1, you can take this as a general formula. Upon assuming x1 is a and x2 is b, and if you assume xn is arithmetic mean of those two previous terms, then xn will converge to the then x1 will converge to the answer a plus 2b by 3. It will converge to the answer a plus 2b by 3. If x1 is a and x2 is b, and assuming a is less than b, then the sequence with arithmetic mean of the previous term will converge to a plus 2b by 3. So in that case, here a is 0, b is 1. So what should be your answer here? It should be 0 plus 2 by 3, which is 2 by 3. And regarding real numbers, any convergent sequence is a Cauchy sequence. In any Cauchy sequence, a convergent sequence. See, for any type of sequence, if the sequence is convergent, it's a Cauchy sequence. But not all Cauchy sequences are convergent. In particular, if you take real number sequence, if you take sequence of real numbers in particular, then Cauchy sequences are also convergent. So any Cauchy sequence of real numbers is convergent. With respect to real numbers, if we're dealing real number sequences, then sequences whose terms are real numbers rather, then convergence and Cauchy are same. They are one and same. Convergent sequence is Cauchy sequence, and Cauchy sequences are convergent with respect to real number. But for general spaces, it may not be so. In any metric space, any convergent sequence is a Cauchy sequence, but Cauchy sequence may or may not be convergent. In some cases, it may be convergent. In some cases, it is not so. So xn is a Cauchy sequence because it is convergent sequence, the Cauchy sequence. And the last option, it is its limit of xn is 2 by 3 because of the formula that I told you. Even in the case if you do not know this answer beforehand, you can just write out some terms. Like if you calculate up to x5, x6, x7, and x8, you can guess the answer is very, very close to 2 by 3 because 2 by 3 is 0.666 something. So if you calculate up to 8 terms or 9 terms, you find that the answer is converging to that number. Even beforehand, if you do not know this answer, by plugging these values like 0, 1 and consecutively manipulating the terms, you find that. So the answer is it's not a monotonic sequence because the first option is not correct, because odd suffix and even suffix will, one part will increase, the other part will decrease. So they, two sides of the limit, the terms will oscillate actually, and this is oscillating but convergent sequence. So this is the first one is not correct. It's not, because the oscillating sequence is not a monotone sequence, because monotonic sequence is either a non-decreasing or non-increasing sequence, but the sequence oscillates on either side of the limit. The answer is either the third option as well as the fourth option. Xn is Cauchy sequence and limit of xn is 2/3. It's a wonderful problem. In fact, there is a general problem also by xn. This is arithmetic mean. You can also work out same problem by choosing xn as geometric mean of two numbers, like root of xn minus 1 into xn minus 2. I leave that as an, I know the answer, but I leave that to, for the same problem, instead of defining xn as xn minus 1 plus xn minus 2 by 2, if you take xn as square root of xn minus 1 into xn minus 2, it's a geometric mean of the two previous numbers. Of course, for that you have to take x1 as positive number, because for defining geometric mean, the number should be positive. Therefore, if you take x1 as some positive number like 1 and x2 as some positive number like 2, if x1 is 1 and x2 is 2, and if you define x1 as square root of xn minus 1 into xn minus 2, the geometric mean of the two previous numbers, see what kind of limit that you find for xn, whether you get the same options, you just check it out, take it as an exercise. For the next question, I define f on 0, 1, closed interval 0, 1 by f of x. This is, remember, for defining Riemann integral, you have to take f on a closed and bounded interval. That is, okay. Usually we take closed and bounded intervals. Usually, such intervals in R are called compact intervals. So you have to take a compact intervals which are basically closed and bounded. You take f of x square if x is rational, and x cube if x is irrational. It's a very trickier question. You are given the define the function in the interval 0 1. So if you just make partitions of 0 1 with some kind of partition like 0 1/3, 1/3 to 2/3, 2/3 to 1, so some subinterval, 3 subintervals or something like that, then you see for any such partition, not necessarily this partition, you take any partition on your own, but for any subinterval that you take which forms the partition of 0 1, because the values are from 0 to 1, x cube will be less than x square. So usually x cube will be more than x square if x is greater than or equal to 1. If x is 1, they are equal. When you choose x is 1, x square will be equal to x cube. When x is greater than 1, x cube will be more than x square. The cube numbers are greater than the square numbers whenever the numbers are greater than 1. But in the interval 0 to 1, the numbers are less than 1 in magnitude, and therefore x cube will be smaller, x square will be larger. So what happens is if you take the lower integral of f, you have to take the infimum value and then sum up. If you take the infimum value among x square and x cube is x cube here. So if you actually try to compute lower integral of f from 0 to 1, you add up x cube. So it is actually this integral, lower integral from 0 to 1 of f will be integral of x cube dx from 0 to 1. And if you integrate x cube, you get x power 4 by 4. If you apply the limit from 0 to 1, you get 1 by 4. So the lower integral or lower limit of this function f, lower Riemann integral is 1 by 4. Upper integral, when you choose upper integral, you choose supremum of each interval and multiply the length of the interval and add. Upon choosing equal interval length, if you add, you get, so this upper integral will turn out to be, you can work out the details later. So the upper integral of f turns out to be integral x square, because this is supremum and this is infimum. For lower integral, you have to choose infimum and then sum, and for upper integral, you have to choose supremum and then sum. So for supremum of any subinterval in 0 1 turns out to be x square. So for calculating upper integral, I need to integrate x square. Integration of x square is x cube by 3. So when you substitute from 0 to 1, you get 1/3. So you see, lower integral is strictly less than the upper integral. If that being the case, f is not Riemann integrable. See, f is Riemann integrable on a given interval only if both lower integral and upper integral exist, and moreover they are equal. So here lower integral, upper integral exist, but unfortunately lower integral is strictly less than the upper integral, and therefore the answer should be first option as well as the fourth option. This is not correct, because you see integral of 0 to 1 f of h dx is 1 by 4. That is not correct. Only the lower integral of f is 1 by 4. Upper integral is 1 by 3. So options 2 and 3 are incorrect. The correct options are 1 and 4. And for this particular question, you can't find a set for which power set is null set. Even if A is null set, the power set will contain one element. Okay, so the first option is incorrect, whereas the other three options are correct. P of A is a finite set for some set A, because I can choose A to be set like 1, 2. See, if you choose any finite set with n elements, then P of A will contain finitely many elements. In fact, the cardinality of such a finite power set of finite set is 2 power n. As you know, if A contains n elements, then P of A will contain 2 power n elements. So I can choose A for which P of A is a finite set. Even I can choose A for which P of A is a countable set. That is also possible. Okay, and I can even choose A to be interval. Like if you choose, see, what is the example of A for the P of A is a countable set? You can take possibly A to be set of all even numbers or even integers or something. And if you take subsets of all those things, you get a countable set, because integers are countable. And what is the example for choosing A for which P of A is a countable set? You can choose A to be any particular interval, like a closed interval or open interval or something like that, so that P of A becomes a countable set, because any interval is uncountable. So if you know the idea of countability and uncountability, you can easily answer this question. Which of the following functions are uniformly continuous in the open interval 0, 1? So regarding the uniformly continuous, instead of writing out the equations, I will give the answer in terms of a graph. I have drawn graphs of all these functions, like 1 by x, sine 1 by x, x into sine 1 by x, and sine x by x in the open interval 0, 1. Of course, this sort of graphs in the extended interval, not just in the open interval. So if you just look at the open interval 0, 1, just interval 0, 1, near to 1 it is 1, and if you go near to 0, the graph jumps very rapidly, very steeply. In fact, when you approach to 0 here, the graph jumps to plus infinity here. So this is graph of 1 by x, the first function. So what happens is, though the function is continuous in the interval 0, 1, because of the steep rise in the graph, it is not uniformly continuous. So usually what happens is continuous function become uniformly continuous if the whole portion of the graph is embedded in a particular strip. Like if it is of like if you take sin x is always a number between -1 to +1, immaterial of what interval, what x value that you choose and what interval that you choose. If you take any value of sin x throughout the boundary, you find that sin x will always be oscillating from between -1 to +1 everywhere. It can't jump more than 1 or less than -1. So this is the idea. So that makes sin x and cosine x both, which is a byproduct of sin x. The cos x is derived from sin x, which is cosine x, and therefore cos x is also a number between -1 to +1. So such functions are uniformly continuous. So here, keeping this simple idea, if you go very near to 0, the graph of 1 by x jumps to a very large number. Therefore, that is not thing. See, actually, the definition says that for given epsilon, the same delta should work. For any point, if the same delta will work in the domain of the function, then the function will not only be continuous, it is also uniformly continuous. Usually what happens is, if you change the point from 0 to 1, the same delta may not be working to you. For each point of choice of a, you have to choose different delta and different epsilon. Okay, so the epsilon delta changes for choice of a, but for uniformly continuous, the same epsilon delta will work, particularly for any choice of a in the domain. If that being the case, then the function will be very, very close to some number. Here also, if you see, if you go very close to 0, either the value is jumping to +1 or it is dropping down. So it's very much oscillating here and there. So this is the graph of sin 1 by x. So because it's oscillating very rapidly, it is, though it is continuous, it is not uniformly continuous. Okay. In fact, the limit even does not exist here. Okay, it's some number between -1 to +1. It's oscillating. The limit even does not exist, so it is not even continuous here. Okay, so limit of sin 1 by x does not exist whenever x approaches to 0 because of this rapid oscillation near 0. Okay, and here, of course, the limit of the function x sin 1 by x is 0 because the sin 1 by x is some number between -1 to +1. But x tends to 0 whenever this term goes to 0 whenever x approaches to 0. This is some finite number between -1 to +1. So some finite number into 0 becomes 0, and f of 0 is also 0. Therefore, this actually will have a limit here, and this is uniformly continuous because you see, whenever x is close to 0, all the values are very, very small. So it is not only continuous, it is uniformly continuous. The same thing applies for the fourth case also. Sin x by x. If you take sin x by x, it can't be more than 1. So when you take this interval, you see this is around 0.8 here. So whenever, if you change values of x, the values of y is between 0.8 to 0.1. It's very small range of difference here. If that being the case, the function will not only be continuous, it is uniformly continuous. The same thing applies here, but not to these two cases. So the answer are third option and fourth option. And for this particular function, as I just told you, sin 1 by x is some finite number between -1 to +1. So leave away this. When x is approaching to 0, this is going to 0. So limit infimum of f of x is what could be the answer? I mean, you can possibly tell about this. Limit infimum of f of x. This infimum occurs for sin x is a function for which you get supremum 1 and infimum -1. So if you take this particular interval in 0 to 1, if you draw the graph of sin x, you see that this has infimum value whenever x is close to 0, this is 0. So the answer is 0. So you get first option as well as this option. Limit of this is 0, this option as well as this option. And for the next question, which is uniformly continuous, I again give the same idea. See, whenever this is for e power x, listen, the first function e power x is here. So whenever x is between 0 to 1, at the point 0, the answer is 1, e power 0 is 1. And at the point 1, it's e power 1, which is e. So from 1 to e, which is 2.718 approximately, there is only a jump of about 1.718. So if you choose epsilon to be as great as delta, like twice greater than delta, if you choose epsilon is 2 delta, then for any point that same epsilon will work. Therefore, this is uniformly continuous because that's not much rising. But if the same question is asked beyond the interval 0 comma 1, then it is steeply increasing. You see, e power x is steeply increasing function. So if you go beyond 1, then the graph of e power x will increase rapidly. So it is not uniformly continuous, though it is continuous. Okay, so you have to choose the answer depending upon the interval given to you. Because for x, this is the graph x from 0 to 1. The function also goes from 0 to 1. So you can choose epsilon is equal to delta here because the rate of increase of f is same as rate of increase of x. So you have to just compare the rate of increase of x with f of x and see how much delta that you can choose with epsilon that you can choose with delta, so that the same number will work for all points in the given domain, in the given interval. So I can choose epsilon is equal to delta here because the rate of increase of f is from 0 to 1. If you move in x-axis, this is from 0 to 1. So that will work perfectly. So this is x is uniformly continuous. If we take third option, tan pi x by 2 here, you see when in the interval 0 to 1, at the point 0 it is 0, but when you move very close to 1, the graph is jumping to plus infinity. Because when x is close to 1, tan pi x by 2 will approach to tan pi by 2, and the left hand limit of tan pi by 2 will be plus infinity. You know, left limit of tan pi by 2 is plus infinity. So this is not uniformly continuous, as we saw in the earlier case for 1 by x. You see, when you go x close to 0, the graph is going to plus infinity. Therefore, such functions will not be uniformly continuous. But the rate of increase of f is tremendously large compared to rate that x increases. So if you move along x-axis, if the rate of f, this is, I mean, these ideas are very simple. So this is not the proof of actually saying that f is not uniformly continuous or f is uniformly continuous. But for students who undertake this kind of questions in the exam, this is just a clue behind getting the answers. This is not the way of proving things. So in the exam, don't do this, but this is in the net exam or exams like competitive exams, you need to just guess the answer. For guessing, this works perfectly, but this is not mathematically so viable, so that you can't take this as a proof. Please remember that it's just an idea to guess the answer. So whenever x is close to 1, the graph of f jumps to plus infinity. Wherever though the rate of x is finite, the rate of f of x is infinite. Therefore, like 1 by x, this is not uniformly continuous, though it is continuous. Okay, in the open interval 0, 1. And for sin x, I told you sin x, cosine x are all uniformly continuous because it can't go beyond the range from -1 to +1. The whole portion of sin x is always like a wave pattern curve, which lies between. It is embedded in the strip from -1 to +1, and therefore it is uniformly continuous. So among these options, you can see that e to the power of x, x, and sin x. This first option, second option, as well as fourth options or functions which are uniformly continuous, whereas the third one is not uniformly continuous. So I have given the graphs for better understanding, because I always feel that using graphs and pictures and wherever possible, teaching through pictures gives more effective reasoning and understanding for students, rather than writing out so many equations and formulas and justifying this is the case, that is the case. That may be work good for experienced faculty or experienced professors, but not possibly good for young learners, especially subjects like analysis. That's one thing that I always feel, that is my teaching technique goes this way. And the last example that I want to tell you, this is graph of x square. You can see that in the interval 0 to 1, x square is from 0 to 1. So the rate of x square, when you take f of x is x square, increases as good as x, because if you take x from 0 to 1, x is 0 up to 1, the unit interval from 0 to 1. Rate of x square is also, x square is 0 when x is 0, x square is 1 if x is 1. So the rate of x square is as good as equal as 0 to 1, because the rate of f in the 0 to 1 of x square is same as rate of x. F of x is x square is uniformly continuous in the interval 0 to 1. But what happens is when you go beyond 1, for example, if you take 1 comma 2 here in the interval, f of 1 is 1, but f of 2 is 4. The rate of f is much larger, like 1 to 4 compared to rate of x. Similarly, if we take 3 to 4, f of 3 is 9 and f of 4 is 16. So f of 3 is 9, that is not here, but I can't show here. So you see, the rate of f is tremendously increasing compared to the rate of x. So whenever x approaches in a unit interval, like 0 to 1 or 1 to 2, if rate of f is almost similar, like it is also approaching to unit interval like 1 or 1.5 or 1.2, it's as close as possible, then the function can possibly be uniformly continuous. But in this case, as you increase x beyond 1, you see the function increases tremendously. The rate of increase of x square or x cube or x power 4 or any such function will increase rapidly compared to the choice of x in that particular interval when you take more than 1. But whereas if you take the interval 0 to 1, x square, x cube, x power 4 will always be very small. That is why in physics you say when theta is small, theta square is small, you can neglect higher powers of theta. That is because in the interval these functions are continuous, like x square, x cube in the interval from 0 to 1, the neighborhood of 0, these functions are very small, therefore they're uniformly continuous. So whether an answer for whether a function is uniformly continuous or not depends not only on the function given but also on the interval given. So in this case, as I told you, that's why I included this particular example here. X square is uniformly continuous in the interval 0, 1, but it is not uniformly continuous when you take more than 1. So the question of writing the answer as uniformly continuous or not uniformly continuous depends not only on the function that is given, but also on the interval given. So this is true for any case, like searching for a limit, searching for a continuity. So function may be continuous at a point in a given interval, but it may not be continuous. So all those definitions are given point wise, and therefore you have to consider not only the underlying property but also the interval, the points given in the question. So you have to read the questions very carefully in attempting problems in analysis. So little care should be taken there. You can't jump to conclusions arbitrarily, and that will lead you to wrong answers, eventually getting incorrect marks and losing your marks. Incorrect answers will lose your marks, so you can't be qualified there. So I finish my talk with this. This is what I have to. I have discussed nearly more than 30 problems here, and all these problems except the last example for x square were asked in the recent papers, like past 5 to 6 years papers. I will do a few more questions if there is an opportunity for me. Uh, uh, I thank our HOD, Professor R. Venkatramanan, and all the faculty members who supported me in this program for doing this, my colleagues and everyone who be part of this for making what little I know to share with you. There are questions you can ask. Sir?
Sir?
So if there are any questions, people can ask.
Okay, sir.
Sir, no questions in chat box, sir.
Sir, no question, sir.
Then either there are two options only, as I told you. Either they understood completely or does not understood completely. So either A or A complement. Okay. That being the case, I think we can close out this session.
Okay, sir.
So I'm happy to be part of the C4 session and looking forward to do more classes if there is an opportunity. Thank you.
Thank you. I need to multiply thank you word 1,000 times to match it with your efforts, sir. We wish to express our gratitude to our resource person for being with us on this event. Your presence and gentle words are a source of encouragement for all of us, sir. Thank you, sir. Thanks to Professor Venkatramanan, Head PG and Research Department of Mathematics, for organizing this C4 workshop, Chase, Crack, Conquer, and CSIR Net. Thank you, sir. I am very proud to inform about our next webinar titled Application of Epidemiological Model to Quantify the Spreading of Fake News in Social Media. Our resource person, Dr. Pooja Kurana, Associate Professor, Mathematics, Department of Applied Sciences, Faculty of Engineering and Technology, Manav Rachna International Institute of Research and Studies, will be held on 7th November at 10:30 a.m. Our next C4 session will be held on 7th November at 6 p.m. Thank you. Thank you.